page 345, we're going to do a review of topic 6, starting with our vocabulary. So number 1, a or an blank is an entire group of objects from which data can be collected. And that would be a population. Number 2, making a conclusion by interpreting data is called making a or an blank. And that would be making an inference. Number 3, a or an blank is one that is true about a population based on a representative sample. And that would be a valid inference. And number 4, a or an blank accurately reflects the characteristics of an entire population. And probably would be best said by a representative sample. Probably here, if we did a random sample generally should be a representative sample anyway. So we'll probably be in good shape either way with that one. So we look at this lesson 6.1 was on populations and samples. So they've got some definition stuff over here for you just to refresh your memory on that. Population we've already talked about. Sample is kind of a part of that population that we're asking. Hopefully it's a representative sample that's going to accurately represent the whole population. And in a random sample, everybody has an equal chance of being included. And so for that reason, like I said previously, a random sample should be also a representative sample, should give us a representative sample. So if we look at number 1, Anthony opened a new store and wants to conduct a survey to determine the best store hours. Which is the best representative sample? A group of randomly selected people who come to the store in 1 week, a group of randomly selected people who visit his website on one night, every person he meets at his health club one night, or the first 20 people who walk into his store one day. So the question, what is the best representative sample? Some of these may be representative samples, but maybe not the best one. So the best one would be A. We're asking people that actually come to the store, and we're asking over a 1 week period of time. For that reason, that's going to be obviously the website. We don't even know if that has to do with the store. The health club does not have to do with the store. First 20 people that walk in the store one day could help, although it's only 20 people versus for a whole week randomly selecting. Also, if you're asking the first 20 people that walk in the store that day, they're going to maybe be more inclined to wanting earlier hours as opposed to later hours. So they're a little bit biased there as well. If we look at number 2, Becky wants to know if she should sell cranberry muffins at her bakery. She asks every customer who buys blueberry muffins if they would buy cranberry muffins. Is this a representative sample, and explain? Probably on this one we would have to say no, because it's not a random or systematic sample. We're just asking people that are buying blueberry muffins. And so if you did not buy a blueberry muffin, you could not even possibly be included in our survey. That's kind of the problem with this one. You know, if we just randomly asked every certain people, you know, that came in, or if we asked like every 5th person or something like that, that would be okay. But since we're just asking people that buy the blueberry muffins, I don't know, there could be a taste issue there where people that like blueberry may be more inclined or less inclined to liking cranberry muffins. So giving everybody a chance at least to be included in our sample would be a better option. Number 3, Simon wants to find out which shop has the best frozen fruit drink in town. How could Simon conduct a survey with a sample that is representative of the population? So always check what it is that you're talking about. Best frozen fruit drink in town. And so we're trying to figure out how he would conduct a survey representative of our population. So one option is he could stand by a place that does not sell frozen fruit drinks and ask every 5th customer about their favorite local frozen fruit drink shop. Okay? If you went to every single shop and maybe asked some people, the same amount of people from each one of those, that would be at least better than just asking from one place. But if you just, you know, are asking random people like this that are not necessarily associated with a certain spot, you might get a little bit more random answers. One disadvantage of doing what we're saying here is based off of your location. Like if you're on a certain side of town that's close to one of the shops, this may not even be that good of a method either. You might have to go to like different areas. So a little bit of a complex issue maybe of coming up with a good representative sample and not being biased in some way. Lesson 2 is on drawing inferences from data. So inference is a conclusion based off of our sample or samples. And then hopefully if we have a valid inference, if we have a valid sample, we can have a valid inference. So if you look at number 1, refer to the example, and then Polly surveys 2 more samples. Do the results from these samples support the inference made in the example? So in the example, it said that there were 400 students, and she surveyed a random sample of 80 students to find their favorite hobby. And so her inference was that doing crafts is the least popular hobby at Polly's school. Okay, looking at the numbers, that was the smallest number that was there, doing crafts. Okay, so if we look at this table here, we had in the first sample, %, crafts, this is the smallest number. The third sample, crafts again was the smallest percent, it's about 13.3%. And really, without even figuring out the percentages there, we could probably say this, that the results do support the inference doing crafts is the least popular hobby at Polly's school, because again, it was the smallest, had the smallest number of students that voted for that in all 3 samples. We probably should make an additional add-on statement to the end of this to reflect that better. So again, probably being more specific here, just finishing with that statement, because crafts was the least chosen hobby in all 3 samples. All right, then if we look at number 2, it says refer to the example. Giovanni estimates about 200 students in the school favor playing sports as a hobby. Do you agree, and explain? So this one, we got to look at all the information given. It tells us over here on the example that there are 400 students at Polly's school. And so if she's estimating about 200 would favor playing sports. Also, notice it says refer to the example. So we're actually just looking at the example information rather than the samples 2 and 3. So we could add all these numbers together and get 80, or if we're observant, we could notice in the problem that it says there was a sample of 80 students, which I did not do. So that's 80 total. And so if we're looking at this as sports, there was 23 out of 80, and we're trying to find a number out of 400 total students. So this would be our proportion that we would need to figure out based off of that example. So you might notice a pattern here going from 80 to 400. It's multiplying by 5. So 23 times 5. Again, getting that number, if you don't know what that pattern is, take 400 divided by 80 and you'll figure out that. And so then we'd get 115. And so they estimated about 200 students. And so we would have to say no, about 115 students would favor playing sports as a hobby. And again, it may not exactly be 115, but 200 is pretty far off from that. You know, if they said maybe 125 or something, that would be a lot better estimate. 200 is probably too far off based off of what our sample was. The last 2 lessons, making comparative inferences about populations and making more comparative inferences about populations. So if you look at number 1, 2 data sets show the number of days a team member is trained before a 5K race. What inferences can you draw by comparing the medians? So the medians we have to remember. So the medians are where our 2 boxes meet each other. If you want to look at these as 2 boxes separated. So those would be our medians. So we can see the median is higher for Team B. And so we can say Team B members generally trained for more days than Team A members. And then if we look at part B, what inference can you draw by comparing interquartile ranges? Remember, interquartile range is the difference between where the boxes start and end. It's looking at that middle 50%. You could actually subtract those if you wanted to. You could kind of just visually look at it here. Just with how these boxes happen to show up and how they both happen to end at the same spot, you could maybe figure it out without actually calculating the interquartile range. So for that, we could say, depending our perspective, more variability in the middle 50% number of days Team A members trained, because the IQR for Team A is greater than the IQR for Team B. Or you could say less variability for Team B because their IQR is lower than Team A. And number 2, the dot plot shows how long it took students in Mr. Chauncey's 2 science classes to finish their science homework last night. Find the means to make an inference about the data. Okay, so we have to find the mean, which means we have to add all these together and then divide by how many numbers there are. So for the first one, some of these are repeated values, so you could multiply them. Again, technically we should have just a statement here about adding our numbers together. So that would equal 775. And then as a second step, we can divide that by 20 is 38.75. For the second one, again, have a separate statement for adding. When you add those is 700. And then 700 divided by 20 is 35. So based off of that, we could say in general, it took students in the first period class slightly longer to finish their homework than the students in the second period class. Okay, again, it was 38.75 minutes on average versus 35 minutes.